Hi students, continuing from the previous video example, let's look at a similar inequality. Only thing is instead of x, we have the variable y. Modulus of y is less than 7 or the absolute value of y is less than 7. And we go through all the same steps and combining the two inequalities, we get minus 7 is less than y is less than 7. Now, here we have a graphical depiction of this compound inequality. Actually, this compound inequality consists of two separate inequalities. One of them is minus 7 less than y, and then the other one is y is less than 7. Okay, and we have depicted each of these inequalities on the number line. Here we see that it starts from a minus 7. The value of y is greater than minus 7. So from minus 7 onwards, it's increasing towards plus infinity. Okay. But you see that I have an open circle here. That means y never takes the value minus 7. Okay. It is greater than minus 7. That means it begins at around minus 6.999999999, like that. It goes on forever, but never reaches minus 7. Similarly, this inequality here, y is less than 7, this starts at 7 and it is going towards minus infinity. So the value of y is always less than 7. That is, it takes a maximum value of 6.9999999, like that. And that's why I have an open circle here. This open circle is directly above 7, just as here this open circle is directly above minus 7. So if you look at these two inequalities, okay, uh, these were seen as um, equation 3. We can call this equation 3. And we had my y less than 7. That is equation 1. Okay, so let's just call this equation 3. Okay, and of course, this is what y is less than 7. We have it here. And y is greater than minus 7. We have it here, the topmost line or ray. And this is the compound inequality that we got by combining these two. Now, if you look at these two rays or these two lines here, which provide the solution to the inequality, you will see that one of them is moving towards infinity. The other one is moving towards minus infinity, and they are also overlapping. Now, this will make it appear as though y, the solution of y, contains the set of all numbers from minus infinity to plus infinity. So if you take only these two rays moving in opposite directions with an overlap, it would appear that the solution for this inequality is all the numbers on the number line from minus infinity to plus infinity. That is, y begins from minus infinity and goes up till plus infinity. Okay, that is all the numbers on the number line are solutions for y. But then, if you actually substitute the numbers, let us take minus 9 or plus 9 and substitute here. What happens? So let's take minus 9. Now, while minus 9 is greater than minus 7, 9 is definitely not less than 7. Okay? Similarly, if you take minus 9, you will get something like this. Minus 7 less than minus 9 is less than 7. While minus 9 is less than 7, minus 9 is not greater than minus 7. Okay. So we cannot say that all the numbers on the number line from minus infinity to plus infinity can be substituted for y, and that will be the solution for this compound inequality, which is a combination of these two inequalities. Okay. So then what then is the solution? What then is the solution? Well, the solution is only the overlapping parts. Only the overlapping parts of these two rays are the solution to this inequality. So only if you substitute values between minus 7 and plus 7 exclusive, only then this compound inequality would be satisfied. Only if y takes the value from minus 6.99999 to 6.9999, will this inequality be satisfied? Otherwise, it will not be satisfied. And you can check this by substituting those values for y here and see that only those values from here to here will satisfy this inequality. Okay. Only when y is given the values from minus 6.9999 to 6.9999 will this inequality be true. So I hope this is clear to you now. Thank you very much. If you have any doubts, you can ask them in the comments section. Have a nice day.